Hello everyone, welcome to the IIT JAM tutorial number 11 in chemistry, and this is the lecture number 7 of the physical chemistry chapter atomic and molecular structure, and the subtopic of this lecture number 7 is operators. Let's begin with the definition of operators. An operator is a symbol for a certain mathematical procedure which transforms one function into another. That means an operator, this is nothing but a mathematical procedure such as multiplication, division, addition, subtraction, taking root over, taking square. So these types of mathematical operations which transforms a function into another function. For example, if d dx, this is the mathematical procedure, and the function you have taken is x to the power n, then after operating this function x to the power n by this mathematical procedure, which is taking differentiation with respect to x, then another function x to the power n minus 1 with some value is obtained. That means the function x to the power n, this is the function, and the operator is d dx. That means differentiation with respect to x. Then after doing the operation, we are getting some value. This value is n, and another function. What is that another function? That another function is x to the power n minus 1. So this is nothing but an operator. Now operator is generally symbolized by giving a cap. Suppose a cap. Okay, so a cap is actually indicating an operator. Now what about linear operators? Okay, so if a cap is a linear operators for any two functions f and g, then if it's a linear function, then what would happen with operation of f plus g? It will give the result such as this one, separate operation result and their addition. That means a cap f plus g equals to a cap f plus a cap g. For example, d dx, that means differentiation, is an example of linear operator. Suppose if you differentiate two functions y and z, which are functions of x, maybe a function or may not be a function of x, then the result is, it is actually equal to dy dx plus dz dx. So it's an example of linear example. And the Hamiltonian operator, what we have discussed already in the previous lecture during the discussion of postulates of quantum mechanics, then we have got this type of operator, Hamiltonian. So this is also an example of a linear operator. But root over, taking root over, is not at all a linear operator, because root over x plus y is not equal to root over x plus root over y. So taking root over is not at all a linear operator. Now commutator, for any two operators, suppose a cap and b cap are two operators, and then they will commute if a cap b cap equals to b cap a cap, and if it is not equal, then they are not commutating. So there are two possibilities: either a cap b cap would be equal to b cap a cap, or they are not equal to each other. Now if a cap b cap equal to b cap a cap, then a cap b cap commute each other, and in that case it is possible to construct a new operator. What is that operator? Under the cap, it is ab minus ba. This operator is called the commutator, and they are the commutator of a cap and b cap in such a way that this third bracket, that or the squared bracket, and within the bracket a cap comma b cap, that means this is commutator of a cap and b cap. That means this is nothing but equal to, under the cap, ab minus ba, and this is nothing but equal to a cap b cap minus b cap a cap. If these two parameters are equal, that means for commutator they are definitely equal, then their difference must be 0. That means commutator means multiplication with 0. Now vector operator. If I, j, k are unit vectors along x, y and z axis respectively, while d dx, d dy and d dz are their respective differential operators, then the vector operator del this is del, it is defined as I ddx plus j ddy plus k ddz, and this is equation number 29. And if phi is a scalar function, then operating this scalar function with the help of del, that means the vector operator, then this result is called the gradient of phi. Now Laplacian. Laplacian is another operator, and we have already used this operator in Schrödinger wave equation, and by definition it is written as the addition of the double differentiation of the three types of differentiations, that means differentiation along the three axes. So this is Laplacian del squared, and this is nothing but equal to del 2 del x square, del 2 del y square plus del 2 del z square. I repeat, del 2 del x square plus del 2 del y square plus del 2 del z square. So this is the Laplacian operator, and this is symbolized as del squared, and this is equation number 30. Okay, now Hermitian operator. Now suppose a cap is an operator, and sometimes a cap star is the complex conjugate of that operator, and if psi is the function, then psi star is its complex conjugate, and for psi 1 it is psi 1 star, and for psi 2 it is psi 2 star. So in that case, a Hermitian operator can be defined as the equality of these two integrals, and this is equation number 31, and this equation number 31 is also known as the turnover rule. So what are the two integrals? In the left hand side, the integral is psi 1 star, then operation of psi 2 by a cap, then d tau. So this integral must be equal to integration of operation of psi 1 by a cap, then taking the complex conjugate of the result, then taking the product, taking the multiplication or the product of the result with psi 2, then d tau. Okay, so if these two integrals are equal, this is the turnover rule, and in that case this operator a cap is known as the Hermitian operator, and this is equation number 31. And this Hermitian operator is linear in nature, and any physical quantity or dynamic variable represented by a Hermitian operator is observable and measurable. This is very important. So if you trying to find out some value, and that you are doing by using a Hermitian operator, definitely those properties are observable and physically measurable, and due to that reason, this H cap, that is the Hamiltonian operator, is definitely a Hermitian operator. And since it is a Hermitian operator, this is linear in nature, because all the Hermitian operators are linear in nature. Now unitary operator. Okay, this is another condition. If u cap is some operator, then u cap inverse is the reciprocal of that operation. Okay, so if this is the condition, then the integral, equality of these two integral according to equation number 32 indicates that this operator u cap is a unitary operator. Okay, so if you take integration of psi 1 star u inverse cap psi 2 d tau, if this one is equal to integration of psi 2 u cap star psi 1 star d tau, then equation 32 is obtained, and in that case u cap is the unitary operator, and they definitely commute. U cap inverse u cap must be equal to u cap inverse. This is also a linear operator, and the eigenvalues of this operator have modulus 1. That means if psi is operated by unitary operator u cap, and then some value lambda is obtained along with the another function or the same function psi, and similarly for the same thing for the complex conjugates, then in that case two eigenvalues are obtained. One is lambda, another is lambda star, and their product is 1. So the eigenvalues of this operator have modulus 1. Now the linear momentum operators, we have already obtained the expressions of linear momentum operator during discussion of the postulate of quantum mechanics, and it was postulate number 6 where we have already determined the Hamiltonian operator, and during the determination of the value of the Hamiltonian operator we have already obtained equation number 18 to equation number 23, where the corresponding operators of linear momentum and their complex conjugates were obtained like this. So in equation number 18, the linear momentum operator along x-axis was h cross by I dx, and its complex conjugate was minus h cross by I dx. Similarly, along the y-axis, this is the linear momentum operator and its complex conjugate is this one, and along the z-axis the linear momentum operator is this one, and here it is the complex conjugate. Now here in some books you will also find this value as minus ih cross ddx or del x. Why? Let's discuss. Suppose this is 1 by I, then multiply both the numerator and denominator by I, then 1 into I becomes I, and I into I becomes minus 1, and I over minus 1 is actually minus I. So in place of 1 by I, we can also replace this 1 by I by minus I. Similarly, minus 1 by I can be replaced by plus I. How? Minus 1 by I, if you multiply both the numerator and denominator by I, then 1 into I becomes I, and I into I becomes minus 1, and these two minus terms cancel each other, and this I is obtained. So in place of minus 1 by I, you can write plus I. So here, if we repeat these equations 18, 19, 20, 21, 22 and 23, then equation number 18 can also be written as Px cap is equal to minus ih cross del x. Similarly, minus h cross by I can be replaced by plus ih cross del x. Okay. Similarly, this equation number 20, plus h cross by I becomes minus ih cross, and equation 21 minus h cross by I becomes ih cross. So equation 20 becomes minus ih cross del y. Equation 21 becomes plus ih cross del y. Equation 22 becomes minus ih cross del z, and equation number 23 becomes plus ih cross del z. So these are all about the linear momentum operators. Now angular momentum operators. In the rectangular Cartesian coordinates, the angular momentum operators may be expressed as equation number 33, 34 and 35, and the operators are here h cross by I. Also this is minus ih cross, as during the linear momentum operators we have done, and this is minus ih cross or h cross by I into y del z minus z del y. The angular momentum operator along y-axis is h cross by I or minus ih cross within bracket z into del x minus x into del z, and along the z-axis the angular momentum operator in the rectangular Cartesian coordinate is minus ih cross or h cross by I into x into del y minus y into del x. So these are all about equation number 33, 34 and 35. And the scalar product of this linear momentum operator L with itself is L dot L equals to L squared equals to Lx squared plus Ly squared plus Lz squared, and this is equation number 36. And in the spherical polar coordinates, these three equations may be expressed as Lx equals to minus ih cross or h cross by I into minus sine phi del theta minus cot theta cos phi del phi. Ly equals to h cross by I or minus ih cross into cos phi del theta minus cos theta sine phi del phi. And finally, along the z-axis, it is Lz cap equals to minus ih cross or h cross by I into del phi. And the scalar product L square cap equals to minus h cross squared into within bracket 1 by sine theta del del theta of sine theta del del theta plus 1 by sine squared theta into del 2 del phi squared. This is equation number 40. So that's all about the angular momentum operators. And now the Hamiltonian operator, we all know about this. We have already determined this the value of Hamiltonian operator. We have already obtained equation number 26 in the previous lecture number 6, just previous lecture, and expression of the Hamiltonian operator in the rectangular Cartesian coordinates as h cross squared by twice m Laplacian plus v, that is the potential energy, as a function of r and t, that means time. That means the its radial function and time. And according to the spherical polar coordinates, it is expressed as this one. In place of Laplacian, you have to just replace this by del 2 del r squared, and v r t is same. But it is to be noted that all the linear momentum operators, angular momentum operators, and the Hamiltonian operator are Hermitian in nature, and thus they all are linear in nature. Now move on to the questions. So up to question number 24 we have discussed in the lecture number 6. So in this lecture number 7 we have to start from question number 25 for this chapter. So the first question of this lecture is, which of the following is equal to commutator a cap b cap? So commutator a cap b cap, these are the options, and the correct answer is this one. Commutator a cap b cap means a cap b cap minus b cap a cap. Now if we multiply this by -1, then here a negative sign to be put, and due to multiplication with -1 they have to interchange their positions. So this position is taking place by b cap a cap, and this position is taking place by a cap b cap. So it is minus within bracket b cap a cap minus a cap b cap, and this is nothing but commutator of b cap a cap. So the correct answer is the negative commutator of b cap a cap is the right answer, and hence option D is the correct answer. Next, question number 26. What is the value of a cap commutator of a cap b cap plus commutator of a cap b cap a cap? So let's derive. Here are the options, and this is the answer. So this is the question, and then expansion of this part, this commutator operator, as this one. A cap commutator of a cap b cap means a cap b cap minus b cap a cap, and here also the same thing, but here a cap is preceding this one, and here this one is preceding, actually a cap is after this one. Okay, now multiply. This means a cap squared b cap, this means a cap b cap a cap, this means a cap b cap a cap, and this one means minus b cap a cap squared. So this is the result of the multiplication. Same thing, a cap squared b cap minus a cap b cap a cap plus a cap b cap a cap plus b cap a cap squared. So this middle two terms would be cancelled by each other, and as a result we get here a cap squared b cap plus b cap a cap squared. That means this is the commutator of a cap squared b. So the correct answer is option number D. I'm sorry, this is option number B is the correct answer. A cap squared b. Yeah, this is the correct answer. Next, question number 27. The commutator x and d dx is equal to what? So let's derive the answer. Let's operate the function psi by this commutator x and d dx, and the result is, if you expand this, this is x d dx minus d dx, then followed by x. We are operating this by psi, so this means x d psi dx, and this means d dx of x psi. So here x d psi dx minus d dx of x psi. Now this one remains unchanged, x into d psi dx, but this one can be expanded into two factors. First, x constant, derivative of differentiation of psi, then psi constant derivative of x. So here x constant derivative of psi, differentiation of psi with respect to psi, and minus psi into differentiation of x with respect to x. So here these two would cancel each other, and here dx over dx is actually 1. So minus psi into 1 equal to minus psi only. Now if this both psi are removed from the left hand side as well as from the right hand side, then we get the value of this commutator as minus 1. So the correct answer is here option C is the correct answer, which is the value minus 1. Now next question, question number 28, and we have to find out the value of the operator ddx plus x into ddx minus x. So what is its value? Let's determine. So the answer is, let's operate the function psi with this operator. So here ddx plus x, ddx minus x, psi. Now ddx and ddx would merge to form d2 dx square. So d2 dx square of psi, this one. Then here ddx and x means x into ddx of psi, that means x into d psi dx. This one is x into d psi dx. Now minus x, if we merge minus x with ddx, then we shall get ddx of x psi. So this is minus ddx of x psi, and finally plus x minus x product, so that is minus x square. So minus x square into psi. So this is minus x square into psi. Now the result, this is as usual d2 psi dx square. This is d psi x into d psi dx minus, here we have to expand this into two factors, as first one is x d psi dx and second one is only minus psi, because it is actually minus psi into dx by dx. So this is actually minus psi, and finally this one is minus x square psi. So here is the result, this one d2 psi dx square plus this one x d psi dx minus x d psi dx minus psi dx dx minus x square psi. Now this part, these two factors would cancel each other for having opposite signs, and this first term remains as it is. This is the fourth term, it becomes only psi because this is 1, and this fifth term remains as it is, that is minus x squared psi. So what is the result? If you remove psi from the left hand side, then you have to remove psi from the right hand side as well, and finally we get the value as d2 dx square minus 1 minus x squared. So this is the correct option. So by removing psi from both sides, we have the result, and option A is the correct answer. Okay, now next IIT JAM question 2021, and you have to find the value of this integral provided alpha is greater than 0. So here is the result. We know that if the integration limits from minus infinity to plus infinity, then it depends upon the value of n for such an integral which is this type, which is of this type, x to the power n e to the minus ax squared or alpha x squared. And this is, if you change the limit from 0 to plus infinity, then you have to just multiply this by 2. Okay, and if this is for applicable for only n equals to even integer, and if n is an odd integer, then this is simply 0, and here the value of n is 1 because it is x to the power 1, so it is an odd integer, so the result is actually 0. So option C is the correct answer. Next question, if x cap equal to multiply by x and px cap is h by twice by I ddx, then we have to find the value of px cap x cap minus x cap px cap. It may have more than one value. Okay, so let's find out the value, and here is the here's the result. So first of all, we have to operate any function psi with this operator. So this operator is what? Now h by twice pi I ddx of x psi, because here is x, multiply by x. So if you multiply psi by x, then you have to operate by px cap, operate x psi by px cap, and here you have to take simply x in the left hand side, then take the differentiation followed by multiplication with h by twice pi I of only psi with respect to x only. Okay, and what is the result here? Here we get two terms, because here one is x, another is psi. So for x we have to get one value, and for psi we have to get another value. So for x constant we get the value x into h by twice pi I, differentiation of psi with respect to x, plus for psi constant psi into h by twice pi I, differentiation of x with respect to x. And here the second term becomes the third term here. This is as it is, minus x into h by twice pi I, then differentiation of psi with respect to x. Now here we find that this value is actually equal to this value. So the third term is equal to the first term. So both of them cancel each other. Only the middle term remains uncancelled. And here also dx over dx is actually equal to 1. So this is finally getting the value psi into h by twice pi I. So this is h by twice pi I into psi. Now h by twice pi means h cross. So this is h cross by I into psi, or we know that h cross by I is actually minus I h cross. So you can also write this as minus I h cross psi. So the final result is either h cross by I into psi or minus I h cross psi. And if you remove psi, then the result is left behind, which is h cross by I or minus I h cross. So we have two correct answers here. One is option A, h cross by I, and another one is minus I h cross. So that's all about operators. Thank you and have a nice day.